student, today we will learn the chapter sets. Now first we go to understand the meaning of sets. You know who has developed this chapter sets, this theory? You know, German mathematician George Cantor. Okay, so now we are going to define you what is the set. In fact, the meaning of the set is group. But there is a big difference between the set and group. Normally, if 5 things are allotted here, there is no relation between these all the things, then that is group. Okay, but you are writing here A, E, I, O, U. Is there any relation between A, E, I, O, U? You know? Yes, this is the vowels. These are the vowels. Okay, so these are the vowels. You know well, so you can say in a single line that these are the vowels. So it is well defined group, but these all things are not well defined. We can say there are some things in a group, they are together, but we cannot say they are well defined. Okay, so what is the big difference between set and group? The meaning of set is group, but in set we will describe about this type of the group, means this is the well defined group. Okay, so what is the definition of set? We can say well defined group. So students, now we can write this in a single line that a set is a well defined group. It also can be said it is a well defined collection of objects. Okay, so learn this definition about the set. Okay student, in these lectures I will describe so many things. I will not give you too much notes. I will give you descriptions of the things. So next, now as you have told me that these are vowel, but student, if you don't know these are the vowels, if you don't know the English language, these are known as the vowels. Okay, so how you can say these are the vowels? You cannot say. So it will be depend on your knowledge, that you know about this or you don't know about this. If you are going to market and you want to buy some things, a list may be given to you. 1 these things, 2 this thing, 3 these things, 4 these things, 5 these things. You have to purchase all these things from the market, and you don't know about this, what are the relation between these 5 objects, and you know the list only. So when we write this list, okay, and use this curly bracket, only curly bracket we will use, and the name of a list is given with a capital letter A, B, C, D. Okay, then this method is known as roster or tabular method. Are you understanding my language? Roster or tabular method. In this method, you don't know about the relation between this, but you have a list. So it is also known as listing method, tabular method, roster method, or you can say it is listing method. Okay. So in roster method you have to describe the list. Now as if we know the thing what is this, then how we can say? We can say here is a set, let x, and we use a slash, or we can use the slash as such this dot. You can use the slash or this dot. And what is the x? Now you have to describe here. X are vowels of English language. Then this is known as the set. Now as this way, if you describe the set, okay, now this line is known as such that. Read it as such that, or this two dot is known as such that. Now x such that, x are vowels of English language. Okay, and then you know the descriptions or relation between the objects, and this method is known as set builder form. So student, now we can understand a set is a well-defined group, can be defined in two ways. That one is the roster form in which we describe the list, and second is set builder form in which we describe about rule or descriptions of the members. Okay students, now I will give you something more about this. Now taking the same examples, here is A, E, I, O, U. Taking the same examples, I will write here A is member of set A. So this symbol we will use for member of. This symbol means belongs to. A belongs to set A, or member of set A. Member of set A. A is a set of member of set A, or A belongs to set A. This way you can read this symbol. Write this way. This is your symbol. Okay. So this is your symbol, tells the belongs to. Note down this symbol. Okay students, so is D is the member of? No, this is not the member of, so we can cancel this and write D is does not belongs to. D does not belong. Okay, so this way, using this symbol, we can say the member is belong to set A, or member does not belong to set A. Learn it. Okay student, now we will go to the next one. Now if you are in a class and there are 50 students, and name of the 50 students, if some student is repeated and the serial number will be given that 51. So is there a student of 51? No, it is the only 50 student. Okay, so means the name of the member will not be repeat in the set. If you are writing here A, E, I, O, U, this is worthless. This you should not be write or repeat this the member. It should be write only A one times, E, I, O, U. So member should not be repeated. The member should not be repeated in the group. Okay, if A is A1, A is A2, then you can write A1, A2. They are then two members, but so member should not be repeated in the set. Okay, so what we learn that member should not be repeated. Now we will talk about that A, L, L, A, H, A, B, A, D. Write the set using this alphabet in this word. So we write here A 1 times L, and A has already repeated, L has repeated. Then we use H, A is already, okay, it is repeated. So now B, we can write B and A already repeated, and D. So how many members we can write here? We can write here only A, L, H, B, D. Okay, using the letters of this word, we can find a set. Let the name of the set is P. We have write one member only one times. We should not be repeat A 3 times, L 2 times. We should not be remember. We should not be written. Okay, so this way you have to write the set. You should not write the members in repeating way. Okay, students. So after getting this, now we will go to the next things. Now you can tell me in this set how many member. Now A, E, I, O, U. How many members here? 1, 2, 3, 4, 5. So there are 5 members in total. So we can write N A equal to 5. Here N is the number of set A, number of member in set A, that is 5. Are you understanding? 1, 2, 3, 4, 5. Okay, there are 5 members, and this is known as cardinal number. A special name is given of this number, that is the cardinal number. So what is the cardinal number? The number of element when you count in set A, then it is known as cardinal number. Okay, understanding? So now according to cardinal number, we can define the set this way. Let here is only A. How many members are here? And A is 1, and this is known as Singleton set. Singleton set means there is only one member. If there is more than one member, and you can count it, how many members are here? Na equal to 3, and you can count. Okay, then it is finite set. Okay, if there is let set of natural number 1, 2, 3, 4, 5 dash 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 dash, how many natural numbers you can count? No, you cannot count. The number of is this set are infinite, so it is known as infinite set, since you cannot count the number in this set. Okay, are you understanding? Right? So we are talking about singleton set, finite set, and this is examples of infinite set. I will explain all the terms in these lectures, and using your books you can do so many questions after understanding the topic. So this is a lecture, basic lectures. It will describe the basic concept of set. So go through the next one. Okay, are you ready? Okay, so if I will tell you that this is a set, now tell me how many members. So you can say there is 0 member, no member. Okay, it means there is no member, so it will be set as null set, means there is no member, or void set, or we can say it is empty. Okay, means NA equal to 0, there is no member. So empty set can be defined this way, or we can write using this symbol that is known as phi. Read it as phi. So phi, or this curly bracket, when we use, that is empty set or void set or null set, means in set number of member is 0. Number of member is 0. So here how many members in this set is 0. That is the empty set. So I have described you empty set, simple empty set, void set or null set is the same meaning. Okay, student, are you understanding? Now, according to number of set and members, we are saying some things. That here is a wolf, and let set A is WOLF. Okay, now if we write follow, what is the set B? That is F, this one O. Okay, and let here is L. Now we don't write O. Okay, now we write W. So now what you can see, or one example more, F L O W, flow. So that is F L O W. We can see WOLF, WOLF and WOLF. The members are same here also, and NA equal to 4, NB equal to 4, NC equal to 4 also. So we can say A set A equal to set B equal to set B. It is known as equal set. So when the set will be equal, the member should be equal. The two condition, that is the member should be equal, should be same, and NA will be equal. Okay, so this way, if all the members are equal and also the number of total members are equal, then we can say these are the equal set. Okay, students, understanding? So after going this equal set, if we want to be write that now if only number of members are equal, members are not equal, then what we have to write the answers. If examples, if let's set A is A, B, C, D and set B is 1, 5, 6, 7. Now NA equal to 4, NB equal to 4. Only NA equal to NB. Okay, then these are only, we can say, equivalent set. It is not the equal set, but we can say equivalent set, since there are members, are quantity of members are equal. Okay, students, so now we go to the next point. Let in a class group there are 3 students, Ramesh, Mohan and Sohan. Let there are 3 students in a class, Ramesh, Mohan and Sohan, and one teacher enter into the class and he want to be take any one student's choice for cricket team. So he entered into the class and check it very carefully, and he can see that no one he want to be select, neither no Ramesh, no Mohan, no Sohan. So he take this way choice, means empty set. Now what happened if we want to be take one students, he can take the Ramesh only, or he can take the Mohan only, he can take the Sohan only. He will take the one student this way. Now further he should he go through that he want to be take two students, then he can take either Ramesh and Mohan, and he can take Mohan or Sohan, or he can take Sohan or Ramesh. This way he can choose two students, but at the last he think he should be take all three, then he will write Ramesh, Mohan and so on. This way he can choose the students for cricket team. Okay, is there is any other method for choosing the students? Think. Yes, think. No. So there is no choice. Okay, so these choices are full. He can take no students, he can take one student this way, he can take two students this way, he can take three students this way. So from this class, for three students, he can take the team this way. How many teams are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 types of the selections. So we can say these 8 types of the selections all are the subset. We are talking now about subset. Now what is the subset? If we select the members from this group, then these all are subset of set A. A1 is subset of set A. This symbol is read as subset. A1 is subset of set A. And here we can see A8 is subset of set A, but also equal. So this is equal also. Okay, this is equal. So we can write subset and equal. This is subset and equal. Okay, so now this type of the subset, the all members of set A1 is belongs to set A. All members of set 8 is belongs to set A. Then we can read these are the subset. How many subset are here? You can see here. Okay. So students, we can say that if NA equal to 3, we can say here is 3. Number of subset, we can say formula is to the power n. Here we can see to the power 3 equal to 8. So number of subset, using this formula we can find out. Okay, what is the formula of number of subset? To the power n. So in these examples, to the power 3, 8, as we have described here, these 8 subset. So formula is clear to you. Now we can say one subset is equal and other subset are not equal. So we can say number of that are proper subset, and we that is to the power n minus 1. Here in this example, to the power 3 minus 1, 8 minus 1 equal to 7. And what are the proper subset? We can say A1 to A7 is proper subset. Since this is equal, so we can left this, and these are the proper subset. Okay, so proper subset is always one less than the number of subset. Okay, student, are you understanding? Okay, student, we go to the next point. If we want to find out the power set of set A, B, C. Okay, number of subset are to the power 3 equal to 8, since NA equal to 3. Now power set will be collection power set of set A can be write this way: PA. It is the collection of subset. So what are the subset of this? One is empty, one is A. If you want to select one member, as in previous example, use curly bracket. Okay, these are the subset of this one. And if two members are there, A, B, and if two members are there, B, C, and C, A, and last one is A, B, C, A, B, C. Okay, now put it in curly bracket. So 1, 2, 3, 4, 5, 6, 7, 8. So these all when we put in a bracket, these are the subset, then we can find the power set. So after getting the subset, we can find the power set. Okay students, now we go to the next point. In previous example, A1 is subset of set A. This is subset of set A. If you write this way, opposite of this, then we can say A is superset of set A1. A is superset of set A1. Okay, this is the opposite. Okay, now if we are taking any B set, that is A, B, E, and we are taking here, this is not the subset, so we can write it does not subset of set A, not subset, okay, of set A. So if members are not taken from the set A, then it is not the subset of set A. Understanding? Okay students. So students, we are going to be next point to understand the topic more and more. Ready? Okay students. So after understanding the power set, now we are going to be tell you the new things. That is, let for examples, here is a classroom. Here is a classroom, and in your classroom there are 50 students. Okay, there are 50 students in your classroom. There are 50 students. So we can write this way. So the total members of 50 students in your classroom, that is known as universal set. Universal set. And from classroom, if we want to be take some students for any event, then the classroom total number of students is known as universal set. What is the universal set? So we have to deal with the elements and subsets of a basic set which is relevant to that particular context. Okay, so the basic set is called the universal set and is denoted by U. In some book, the other symbol is also noted by this way. Mainly you will use U, right? Now here is a group. Here is a group in your class of let 35 students. Here is a group of 35 students. These students read bio, and also there are other group, they read math. Then we can see some students read bio and math both. And if there are some students also here, those don't read the math or bio, they are outside of this group. Now total are 50 students. Let this one is 35 this one is 25, and some are common and some are left, those students. This way, when we use the diagram, that is known as Venn diagram. In Venn diagrams, rectangles tells the universal set, means base the total members, and from where these are the subset, and we describe the subset by this circle or any circular notations. Then we can say this diagram is known as Venn diagram. So are you understanding what is the Venn diagram? Okay, so using this Venn diagram we can describe so many things. Using this diagram we can describe so many things. Now before going to this diagram we will read some things, okay, then we will discuss on Venn diagram more. Now, operation of set. Operation of set means how we can add, subtract the set. Okay, so first we will go through that. Here is a set A, 1, 2, 3, and here is a set B, 2, 3, 4. Let here is a universal set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we will learn too many things using these examples. Now first A, this symbol use. B, it is known as union or cup. It means plus, add. Okay, so you can add all the members 1, 2, 3, and here is also 2, 3. We will not repeat, so this is the 4. So A union B means add all the members. Okay, A union B. Now if we want to describe this by Venn diagram, we can write here U, and we can write here A, and we can write here B. In we can see 1 is member here, 2 and 3 are common, and here is a 4, and left are 5, 6, 7, 8, 9, 10, which are not the members of set A and B. This is the basic Venn diagram. Now we want to describe A union B. So in A union B, 1, 2, 3, 4, 5, we can shade this A union B. This way, if we shade this, the shaded part is describe the set A union B. Okay, understanding A union B? Okay, now we will discuss A intersection B. It means intersection, or we can say common, or we can say cap. Okay, or we can say product. Now what are the common member in the previous examples? You can see 1, 2, 3, intersection 2, 3, 4. The common members are 2 and 3. So we can write the answer here 2, 3. Okay, in Venn diagram we can see in the previous diagram, now this is the common part. So this will tell the intersection. Okay, so here is the diagram of A intersection B. Are you understanding? Okay, now What is the means of the product? It will be described in other chapters. Now, what is the meaning of A minus B? A minus B means those members belongs to only A, not belongs to B. So we can see here 1 is belongs to only A. So answer is 1. This is the difference. Okay, this one is difference. So now we can want to say B minus A. So in this example 1, 2, B minus A we have to describe. So 2, 3, 4 minus 1, 2, 3. So we can say only 4 is a member which is belongs to B minus A. So answer is 4. Okay, this is the difference. Okay, now symmetric difference. Symmetric difference, that is we have to A minus B union B minus A. It can be written as A circle plus B, or it can be written as also A delta B, and this is the meaning. So we can say here 1 and union 4, we can write here 1 comma 4. This is your answer for symmetric difference. Okay, it's done. Now in the diagram we can describe this way. This portion is A minus B, A minus B, and this portion is B minus A. Okay, so we can say it is only A and it is only B. If we want to find only A, we have to write A minus B, only B, then we can write B minus A. Okay students, now we can also check this way. It is A, it is intersection, this one is only A, so we can write A minus B this way also, A minus A intersection B, only A. Then also we can find this answer, A minus A intersection B. The same answer we will be find. In previous examples it is 1, 2, 3 and it is 2, 3. So your answer is same as it is 1. Okay students, now we will learn that complement of set. Complement of a set. Now if we take the difference from U, let's set A. So we know that U is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in previous example, and A is 1, 2, 3. And what is the difference of UA? That is 1, 2, 3 except 4, 5, 6, 7, 8, 9, 10. So we'll write here answer 4, 5, 6, 7, 8, 9, 10. Okay, it is also denoted by A dash. A dash means U minus A, or complement of set A of A is denoted by A dash. So we can say A dash of dash will be again come, this will be minus from U, then we will find A. So A dash of dash A is A. Okay students, so this way we have learned here union, intersection, difference, symmetrical difference, power set and complement of set A. Are you understanding? So student, go through the next point. So students, after understanding this type of the point, we can say so many things. Now what about A union A? You can say it is A. What about A intersection A? Then you can again say it is A. Isn't it? Think over this. Now what about A union phi? That is A. Now what about A intersection phi? That is phi. This you have to understand better. Okay. So now I am telling you the logically all these things. Now A if X is a member belongs to A union B, then we can say member will be belongs to in set A, or member may be belongs to set B. Okay, think this is the definition of union. If the member belongs to set A or member belongs to set B, then it will become in A union B. Okay, if member does not belongs to A union B, then we can say member does not belongs to A and member does not belongs to set B, and means member will not belong to set A and will not belongs to set B, therefore it will not come in A union B. Similarly, if we talk about member belongs to A intersection B, so what you can say? Member belongs to set A and of course it will be belongs to set B. If A member belongs to both set, then it will be belongs to intersection, means common. If it is not belongs to A intersection B, it means we can say it will be not belongs to A, it will be not belongs to B, or we can use or. If member will be not in A, then it will not come intersection. If member will be not in B, then also it will be not come in B. Now, what is the meaning of X belongs to A minus B? So we can say X belongs to only A and X should not belongs to B. Okay, or we can also say X belongs to A and X should not belongs to A intersection B. Okay students, now we can say X belongs to A, it will be tells X does not belongs to A dash, and also we can say X does not belongs to X belongs to A dash, it will be tells that X does not belongs to A. Are you understanding this logic? Go through this logic, these are the definitions. Now we can prove some De Morgan theorem. I will write the letter only. If A union B dash, then we can say A dash intersection B dash. Similarly, if A intersection B dash, then we can say A dash union B dash. This is a very useful theorem. If you use this in probability and any times, then you can find out this. You can use this type of the theorem. Okay students, so now we will go to some basic formula. If in the Venn diagram we can see members belongs to A and B and union, there is no member outside, then we can say NA plus NB. This one is NA and this one is NB minus intersection minus NA intersection B, because this intersection is adding in this and adding also in this, so 2 times, so we write here 1 times. We can write NA union B, and then A union B is equal to universal set since there is no member of outside. This is a very basic concept. Now we can say if these 2 members are this way, then we can say NA set A intersection set B equal to phi, then NA intersection B equal to 0. These are known as disjoint set. Disjoint set. Then this formula will be NA plus NB minus 0 equal to NA union B. Okay, so we can write 0, so we can write here NA plus NB equal to NA union B for the, we can say, for this disjoint set. Okay students, what is the disjoint set? According to disjoint set, you can use so many formulas. Whatever the formula you want to be described, that will be from this Venn diagram. Now here are 3 groups. Here is A, here is B, here is C, and here is universal. There is no student to outside, there is no member to outside. Then this is A intersection B, and this is A intersection C, and this is B intersection C, and this one is A intersection B intersection C, and these all are unions. So now the formula will be NA plus NB plus NC minus NA union B NA intersection B minus NB intersection C minus NC intersection A plus NA intersection B intersection C equal to NA union B union C. Using this formula, we can find so many things. Okay. So students, we can make so many formulas for 4 circles. Also 4 circles we can draw the formula, but in these lectures we will describe only about this only, right? So student, in these lectures I am telling you only these points, and further if we have a time, so we will give you some notes, some exercise on this topic. So at this time we are stop this. Okay students, so wait for next video.